Okay, so another distribution that we talked about was the normal distribution, right? So we also said that the normal distribution is just a bell curve, right? Centered at mu, right? So remember this was just equal to mu, which is the population mean. What we basically wanted to do was find area, right? Underneath this normal curve, right? The notation that we're using is this, right? So this just means x. This tilde just means it's distributed, normal with a mean of mu and a standard deviation of sigma. And the way that we go ahead and find probabilities, right? We go ahead and use the normal CDF function, only the normal CDF, right? Whenever we want to find probabilities. So to find probabilities, we got to use normal CDF, right? LB just stands for the lower bound, right? So you can write lower bound if you'd like. UB just stands for upper bound. Here is the mean mu, whatever they give it to us. Standard deviation is just sigma, whatever that is, right? Okay, so you can go ahead and copy this down, and you can try to attempt this problem again, just like you did with the binomial. I will go ahead and start the problem, right? This is a completely made up problem, as you can tell. So my example is cute and adorable kittens have a weight that is normally distributed with a mean of 5 pounds and a standard deviation of 3 pounds. If I randomly select one kitten, right, what is the probability that this kitten will have weight, I forgot the T on weight, between 4 to 6.5 pounds? Okay, well, there's a couple things that you need to kind of watch out for, and that's the keywords normally distributed, right, with a mean of 5 and a standard deviation of 3. So let's use this notation to write down what we know. So we know that x is normally distributed with a mean of 5 and a standard deviation of 3, right? So we already know what mu is and we already know what sigma is. Okay, what is the probability that we're looking for? We has to be between 4 and 6.5, right? So if I were to draw a normal curve, right, and always try to draw a normal curve because it really just helps you, right? The mean is centered at 5, so 5 is right here, 4 is here, and here is 6.5. 6.5. Oh, that looks like 4.5. But this is a 6. Okay, and basically what we're looking for is the area bounded between these two numbers, right? That's basically what we're looking for, right? So the probability that x is between 4 and 6.5, right? So what are we going to use? We're going to go ahead and use normal CDF, right? So we're going to use normal CDF. What is my lower bound? My lower bound is just 4. What is my upper bound? My upper bound is 6.5. Right? What is my mean? My mean in this case is going to be 5. What is my standard deviation? It's going to be 3. Okay, so we're going to go ahead and use the calculator, right? So I'm going to go ahead and put it over here. So it's exactly the same thing that we were doing before. So let me clear this. Seconds vars, right? I'm going to go down to normal CDF. We do not want PDF. Lower bound, right? In this case, it's going to be a 4, right? My upper bound is going to be a 6.5. My mu, my mean is going to be a 5, and my standard deviation sigma is going to be a 3. So make sure that you really know what these two letters stand for, right? Or else we're going to be really lost. Mean and standard deviation, right? Okay, paste. What are we going to get? 0.3220. So 0.3220. So about 32%, 0.2%. Okay, so the chances that I will randomly select a cute and adorable kitten that's between 4 to 6.5 pounds is about 32.2%. Okay, now what is the probability of at least 7 pounds? Okay, so let me go ahead and graph it one more time. What is my mean in this case? My mean is still 5. My standard deviation is still 3. 7 is going to be over here. Now, what does at least mean, right? So if I say at least 21 to get into the club, it means that I have to be 21 and over, right? So at least 7 means that I have to be 7 and over. So it's going to be all of this area. So that's what we're looking for, okay? So what are we going to use? Normal CDF. Now my lower bound in this case is going to be 7 because that's where the area starts. Now where does the area end? Well, my area ends all the way to infinity, so I just got to write a really, really big number, right? So I can write 1, 0, 0, 0, 0, with a whole bunch of zeros if I want, okay? What is going to be my mean? My mean is still equal to 5. My standard deviation is going to be equal to 3, okay? So now I'm going to go ahead and my calculator, and I'm going to get, let me put second vars, go down to normal CDF, right? My lower bound in this case is a 7. My upper bound is not going to be a really big number, right? So 1 million, whatever, how many zeros you want to put. My mean is still 5. My standard deviation is 3, and I'm going to paste it. Now, if you have the TI-36, you don't really need to write this one with a whole bunch of zeros. You already have a really big number entered already. So I'm going to press enter, and I'm going to get 2525, I guess, around there. So around 0.25, 25. So this is about 25.3%. Okay. And notice that based on the area, 5 here is basically the median also, right? So 50% of it is below it, right? So we should expect this area to be less than 50%. And in this case, we got it to be 25%. Okay, so that's basically what we did. I'm going to shoot you guys another video about how to do the opposite when I give you the probability now, and now you got to figure out the value. Okay.